Hi folks, let's take a look at question number 8 in the 6.2 disc and washer method practice. So let's start with question 8. Find the volume of the solid of revolution generated by rotating the area between the graph of f of x equals x and g of x equals 1 over x over the interval from 1 to 4, and we're revolving this around the x-axis. All right, well, let's get started with our graph. So the graph of f of x equals x is a pretty easy one. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. And I'm going to go ahead and connect those. All right, and the graph of 1 over x, same thing, let's plug in some numbers. So when I plug in 1, I should get 1. When I plug in 2, I will get 1/2. When I plug in 3, I will get 1/3, and when I plug in 4, I'll get 1/4. And so I'm going to go ahead and connect those down here. And there is another part to it that goes up this way, okay? But we won't actually need that part for the graph. All right, what about our bounds? Well, we're going to be starting at 1, and we're going to be finishing at 4. And our axis of revolution is our x-axis, or y equals 0. All right. Let's draw our reflected part first. So 1, 1, 2, 2, 3, 3, 4, 4. That gives me this part. And then 1, and I get 1/2 and 1/3 and 1/4. So I get sort of like a round part, and then I have this part right here. So it's smaller than the hole in the other graph in number 7, but this one is also a good case for washer method, which we can say is pi big R squared minus little r squared. Okay? And let's do that same color coding we did last time. Let's draw a radius. So I have a radius here, a radius here, a radius here. And for all of those radii, the top curve is pink and the bottom curve is purple. So the pink one is going to be the outer radius because it has a bigger distance from the axis of revolution, okay? So let's draw our circle. All right. Now the inner radius is going to be the one closer to the axis of revolution. And the purple line is closer to that axis of revolution. So our washers or donuts are going to look something kind of like this, okay? All right, let's set up our integral. Volume equals the integral of area. I'm going to say dx because I'm stacking the blue lines along the x-axis, and those blue lines are perpendicular to my axis of revolution. That means my bounds will be x values, and we can call them a to b. So we have the integral from 1 to 4 of pi. Big R squared is x squared minus the little r squared is 1 over x squared dx. Okay, let's go ahead and simplify. So pi times the integral from 1 to 4 of x squared minus 1 over x squared dx. And I'm going to go ahead and write this one almost the same, except I'm going to write the second term as x to the negative 2. And that's just a reminder for me that when I integrate, I need to use the power rule. So let's integrate. X squared becomes 1/3 x cubed minus 1 over negative 2 plus 1, x to the negative 2 plus 1. Plugging in 4 and plugging in 1. All right, let's clean this up before we plug in our bounds. Pi times 1/3 x cubed plus 1 over x. And I'm going to plug in 4, and I'm going to plug in 1. 1/3 times 4 cubed plus 1 over 4 minus pi times 1/3 times 1 cubed plus 1 over 1. So I have pi. I have 4 times 4 is 64. Plus 1/4 minus 1/3 minus 1. This will give me pi times 63 over 3 plus 1/4 minus 1. And that will reduce to pi times 63 divided by 3 is 21. 21 minus 1 is 20 plus 1/4. And so that will give me 81 pi over 4. And 81 pi over 4 represents the volume of this shape when I have revolved it around the x-axis. All right, that's it for question number 8. We've got 2 more practice problems, so come back and check out example 9 and example 10. See you there.